For the National Estuarine Research Reserves, our system-wide monitoring program, or SWMP, is how we take the pulse of America's coastal waters. Using the same procedures at each reserve, we're able to provide information that show national trends in water quality through time.
I'm the monitoring coordinator here at the National Estuarine Research Reserve on Barker's Island on Lake Superior. What I take care of is what's called the SWMP system, the System-Wide Monitoring Program. There are 28 NERs, 28 reserves around the country, and we all do similar monitoring. Behind me is the monitoring site at Barker's Island, or our SWMP site. This one has a sonde similar to what this is. Down here in this box, underwater, there's a solar panel there to give it power, and it sends the data that it's reading to my computer, so I can see what this one is telling me. The sondes all take, across the system, take the same basic water quality indicator things like dissolved oxygen and pH and conductivity, turbidity, depth, temperature, all those things that give us a good idea of how healthy the river is. So this sonde has a number of sensors on the bottom, and one just like this is underwater right behind me. We also do analytical work. Once a month, we go to our SWMP sites and we take samples of water and we bring them back to the lab and analyze them for phosphate, nitrate, nitrite, ammonia, and chlorophyll A. Again, these are basic water indicators. The idea behind the SWMP monitoring site is long-term good quality data. A lot of projects, if they're grant funded, the grant might last for 2 years. The SWMP system has been built and running for several decades at some sites so far. So year-round, they have 15-minute data on water quality with a data sonde like this, 15-minute data on weather, and monthly nutrient analyses. And that builds a long-term record that can be used by managers, researchers, and students. One of the things that we analyze for when we analyze grab samples as part of the system-wide monitoring program is chlorophyll. So we use a filter, and we filter 100 milliliters of the water through that filter. Chlorophyll stays on top of the filter, and we extract that later with acetone and run it on the fluorometer as a measure of how much chlorophyll A is in the water. And natural resource managers use that to look at productivity. We're analyzing on the seal, the auto-analyzer, for nutrients, so that's one look. And looking at chlorophyll tells you how much biological productivity is going on. So that's a good long-term look at the health of the watershed. Looking at nutrients is one way of checking the overall health of a watershed. What's a natural nutrient level, and what is it that humans might be increasing nutrients too much? Increased nutrients will lead to algal blooms, which leads to low dissolved oxygen and possibly fish kills. So we want to make sure that we have a balance between the nutrients and the algae. That's why we look at both for our long-term monitoring component. We have to make a series of reagents that are used on our auto-analyzer, and we run ammonia, phosphate, nitrite, and nitrate. And today we're prepping to do digests for total phosphorus and total nitrogen. This is the auto-analyzer. We run nutrient samples on this. Right now it's analyzing total phosphorus and total nitrogen. The results of each sample create a peak, and the machine finds that top of the peak and can do the calculations to tell us what the concentration is.
The SWMP program allows us to know what's happening today in the river or what's happened for the last 5 years, and we'll continue to collect data long into the future. At the reserve, we care about the health of the St. Louis River and its tributaries because the river forms the headwaters of Lake Superior, which is the headwaters of the Great Lakes. Together, 20% of Earth's surface freshwater.